part 8 of Polytechnic lecturer previous year question discussion video. Okay, so we are going to see some more questions in this video. The first question is, you'll be seeing the questions on board. Okay, so the first question is, two identical transistors having beta of 50 each are connected as Darlington pair. So Darlington pair is a type of amplifier. We have discussed in a video on all the basic variations of amplifiers. Okay, so the Darlington pair is another type of amplifier, and the question is asking the current gain beta of the amplifier. That is, when two identical transistors are connected on a Darlington pair type of connection, what will be the current gain or the beta value of this Darlington pair? That is a question. Okay, so here we are using two identical transistors of beta. Beta is the common emitter current gain. So the value of beta is equal to 50. So there are two transistors. So beta 1 is equal to 50, that is equal to beta 2. Okay. Now, when a Darlington pair is formed out of these two transistors, the overall gain is given by beta Darlington will be approximately equal to beta 1 into beta 2. So this is a relation. So in a Darlington pair, there is actually two transistors connected. So if beta 1 is the current gain of the first transistor and beta 2 is the current gain of the second one, then the total beta, that is the total current gain of the combination, will be approximately equal to beta 1 into beta 2. Okay. So here both the beta values are same. So you have to take beta 1 is equal to beta 2 equal to 50. But in some cases it will be different. Okay. So here you have to take 50 into 50, and that is equal to 2500 will be the value of your Darlington pair's current gain value. Okay. So the correct answer is option C. So the equation here is beta Darlington is approximately equal to beta 1 into beta 2. Or you can take it as equal to. Okay. So the first question correct answer is option C. Moving on to the second question. Okay, this second question is connected to the RMS voltage. Okay, so the RMS voltage at a transformer secondary is 6 volt. So the question is giving us VRMS, that is RMS voltage, that is equal to 6 volt. The peak value is dash. So we need to find what is the V peak. Now there is a very simple relation between these two voltages. V peak is equal to V RMS into root 2. This is the relation. Or in other words, you can write it as RMS value is equal to peak value by root 2. Okay. So please note down these two relations because it will be useful in order to solve the problems related with transformers and all. Okay. So anyway, here they are just asking the relation between peak voltage and RMS voltage. So we need to find the peak voltage. RMS voltage is already given to us. So we have to just substitute it here. And the value will be V peak is equal to 6 root 2. Okay. That is 6 into root 2. And on solving, you will be getting the value is equal to 8.485, or approximately you can take it as 8.5. Okay. So 8.5 volt is the correct answer, which is option C. So the second question correct answer is option C. Okay. Third question. So the third question is connected with the diodes. Okay. When a diode is tested using an ohm meter, okay, it indicates high resistance in both direction. The conduction of the diode is dash. Okay. So you can denote a diode like this. There is an anode, there is a cathode. Okay. So this diode, we can say it as that is a very basic diode or a PN junction diode. We can say it as unidirectional switch. Okay. And this is a basic property which we use in rectifiers. So when the diode is conducting means the switch will be closed. When the diode is non-conducting means the switch is open and there will be high resistance on both these terminals. Okay. So when the diode is conducting, it will work. When it is not conducting means it will be open, right? So this is the basic principle that we use in rectifiers. That is for converting AC current to DC current, we use rectifiers. And this property of the diodes, that is a unidirectional switch, this property is being used in this rectifiers. Okay. Now here the question is, when a diode is tested, it is observed that there is high resistance on both directions. In both directions there is high resistance, that is in this direction and also in the opposite direction it is having high resistance, means the diode is actually not conducting or it is in open connection. Okay, so the meaning is it is open. Correct answer is option A. Okay, so this question is actually dealing with the very basic property of diode, that is whether it is conducting or whether it is not conducting. Here it is open, so it is, that's why it is having high resistance on both the directions. Okay, so correct answer for the third question is option A. Fourth question is connected with an IC. So the question is IC 7476 is dash. So if you type IC 7476 in Google, you can see a lot of data sheets connected with the JK flip-flop, because it is a JK flip-flop IC. Okay. So if you have worked in the digital laboratories, or if you have done experiments with digital ICs, especially flip-flop ICs, this is actually a flip-flop IC. Okay. So it is a IC for JK flip-flop. Okay. IC 7476 is IC for JK flip-flop. Correct answer is option C. Okay. Next question. That is the fifth question. The output of a particular op-amp increases 8 volt in 12 milliseconds. The slew rate is dash. So if you know the definition of slew rate, you can answer this question. Slew rate is defined as the rate of change of voltage with respect to time. That is actually slew rate. So here it is given that there is an increase in 8 volt. Means the change in voltage is given as 8 volt. Okay. 8 volt is a change in voltage. Okay. And in what time? In time t is equal to 12 milliseconds, there is a change in 8 volt. So what is the slew rate? This is a question. Okay. So the definition of slew rate is actually change in voltage with respect to time, and most commonly we are taking change in voltage with respect to either milliseconds or microseconds. Okay. So here it is given in milliseconds. So we'll take slew rate, its definition also if you see the options. So sometimes you have to also look into the options. If you see the options, you can see all options are having unit as volt per millisecond. Okay. Volt per millisecond is the unit given for all the options. So this indicates that here we are calculating the slew rate as rate of change in how many volts with respect to the time in milliseconds. So that's why we are having the unit is volt per milliseconds. Okay. Here directly it is given as change of 8 volt and time is 12 milliseconds. So here you don't have to convert the time from millisecond to any other values. In some questions, all the options will be given in volt per microseconds. Then you have to convert the millisecond to microseconds. Okay. See, I am talking about the slew rates unit. The slew rate unit will be taken either volt per millisecond, or if you search about the slew rate, you can see that the unit can be volt per millisecond or volt per microseconds. That is how much change in voltage is happening in this much of milliseconds or in this much of microseconds. Here it is volt per millisecond. So you can directly take these two values. Otherwise, you have to convert millisecond to microseconds. Okay. So that's what I'm talking regarding the unit. Okay. Here you don't need to convert or anything. You just have to take the values as it is. That is 8 by 12. Okay. And on division, you'll be getting the answer is option D, 0.67 volt per millisecond approximately. Okay. Correct answer is option D. You should be knowing all these basic things. See, if you examine the question paper, you can see that mostly the questions are dealing with only basic concepts, only basic equations they are asking, not going into too much deep of it, only on the creamy layer of your subject concepts. Okay, all the important equations only they are dealing with. They are not going too deep into the equations, that is the derived equations, all those things they are not asking for numericals or anything. So all the basic equations you should be knowing. Here it is an equation connected with the slew rate of the op-amp. So this is also important. Okay, anyway, correct answer is option D. Moving on to the sixth question. Sixth question is from digital electronics. So when you are studying digital electronics, don't skip this number systems and conversions. You will be having at least 2 questions from this area. Okay. So here the question is actually an octal to decimal conversion. A number is given in 12_8. This is actually 12 to the base 8. Okay. Since the question is typed in this form, you will be getting or seeing as 12_8. It is 12 to the base 8. So you have to convert this to decimal. How will you convert it? That is 1, 2 to the base 8. The position values are 0 and 1, right? So it is 8 raised to 1, 8 raised to 0. Take the products off. That is 1 into 8 raised to 1 plus 2 into 8 raised to 0. And you will be getting as 8 plus 2 into 1, that is 8 plus 2, that is 10. 10 to the base 10 is the answer. Okay. We have done a separate video on number systems and conversions. Please do watch that video. It is in the digital electronics playlist. Okay. So the answer here coming as option C. Okay. Sixth question, correct answer is option C. Seventh question. Seventh question is a theory question. Noise margin is expressed in A, decibel, B, watt, C, volt, D, phone. Correct answer is C. Noise margin is actually the ability of a gate to tolerate the fluctuations in voltage levels. There can be some fluctuations in the voltage levels given to a gate. Any gate it can be. So how much it is having the ability to tolerate the voltage level variations. So that is noise margin, its definition. Okay. And this is expressed in volts. How much voltage it can tolerate. How much voltage change it can tolerate. So the unit is volt. Okay. Correct answer is option C. Volt is the correct answer. Eighth question. That is the last question that we are going to discuss in this video. Okay. Eighth question is, in class B amplifier, the Q point is set slightly above cutoff. The purpose is to dash. A, avoid crossover distortion. B, increase efficiency. C, reduce power dissipation. D, increase gain. Okay, so before talking about the purpose, let us see what is a Q point. In a very brief manner, I will be telling you, because there is a video in analog electronics playlist. That is the video explaining about the quick revision of BJT equations and all. And there is a video on load line, that is how to draw the load line and how to find the Q point. While explaining some BJT numericals, I have included this topic also, that is drawing of load line and finding of Q point. I'll share that in description box. That video's link I'll be sharing in description box. In that I have explained each and every step to draw the load line and finding the Q point. Okay, here I'll be briefing it anyway. So the load line we are generally drawing between collector to emitter voltage VC and IC. Okay. So by drawing, that is, we are drawing the lot line in between collector voltage and collector current and collector to emitter voltage. Now what is Q point? Q point is the point that is getting intersected onto this lot line from these two axes. And what is these 2 points? I'll tell you. This point is the value of collector current, when no signal is given. Okay. No signal collector current. How much is it? We'll calculate. And we'll mark that point here in the IC axis. And also the no signal PC, that is collector to emitter voltage, we'll calculate and we'll find that point in this VC axis. And then we extend this point towards the lot line, and the point that is getting, these two lines are getting intersected in the lot line, that point is called Q point. Okay. So this Q point is actually determining used for determining the stability of this amplifiers. Okay. So here the question is connected with the class B amplifier. So I would suggest you to watch the video which I am going to link in description to understand the concepts of load line, Q point, everything. I have explained in very much detail in that video. Okay. So it would be useful if you watch that video. Okay. That is my suggestion. Okay. So here the class B amplifier, the Q point is set slightly above cutoff. Okay. So this Q point can be set to various regions, cutoff region or any other regions. So here it is, the Q point is set slightly above cutoff. Why? That is a question. The purpose is to avoid crossover distortion. Again, this question is also very important. There is a problem that is occurring in all the push-pull amplifiers. There is class A, class B, and all the push-pull amplifiers. There is a problem called crossover distortion. Again, this concept I have explained in one of this previous year question discussion videos itself. Okay, I think in part 3 or 4 I have explained about this crossover distortion. So crossover distortion is So this crossover distortion is actually happening because we know that for a transistor, in order to turn on the transistor, this is a transistor, there is a voltage called base emitter voltage, VB. This voltage is primarily helping to turn on the transistor, right? And this voltage is actually the built-in potential of this junction. We know that there are PN junctions connected in a transistor, right? 2 PN junctions are there. So in order to turn on the transistor, we are actually providing a voltage VB to, that is, if the common emitter configuration that we are using, then the VB voltage should be greater than 0.7 volt. Okay. Only then the transistor will be getting turned on. Okay. So when it is crossing the 0 point, it won't suddenly start conducting. Only when the voltage is greater than 0.7, the transistor will conduct. Okay. So this problem is called crossover distortion. Okay. So this crossover distortion, in order to avoid the crossover distortion, we are biasing the Q point slightly above the cutoff. Okay. So first of all, please do watch this video on how to draw a load line and this marking of Q point, and also watch the video on the crossover distortion. I'll link a video in description. In that I've explained about the crossover distortion in very detail. Okay. I'll link these 2 videos in description. So if you have some trouble in understanding what I've just explained now, I'm sure that these 2 videos will help you to understand what is a crossover distortion and what is that is how to draw load line and marking of Q point. So anyway, you should be knowing that there is a problem called crossover distortion in the class B, class A, and all the push-pull type of amplifiers. Okay. So push-pull type of amplifier means the amplifiers in which 2 transistors are connected in a manner like this, and when one transistor is on, another one is off. Next, when this is on, this one is off. So it is a push-pull connection. Okay. So what will happen here is, Only when this 0.7 voltage is reached, the transistor will actually start conducting. Okay. So due to this problem, when the output or when the signal is crossing the zero line, there will be some delay to start the output waveform, because there is 0 to 0.7, this much voltage it is not actually producing as output, because only when 0.7 is reached, this transistor will start conducting. Okay, so that is the reason. Okay, anyway, just watch the video on crossover distortion also. Okay, you'll get a very clear idea. Okay, so here the correct answer is option A, that is in class B. Why we are actually going for this type of Q point biasing? Because we want the crossover distortion to be avoided. Correct answer is option A. Okay, so these are the questions that I've included in this video. So I'm really hoping that you understood the questions. I've tried to give maximum explanation to each of the questions. That is, whichever areas are coming along with that questions, I've tried to explain. So I'm really hoping that you understood the concepts and the question answers. So if yes, please do give it a thumbs up. Please do share it with your friends who's preparing for this examination or any other competitive examination for that matter, because these type of questions are always useful whether you are preparing for this exam or some other exams. Okay, and also please do subscribe to the channel. Please do tell your friends also to subscribe to the channel. Thanks for watching and keep on watching.